name is Muhammad Irfan Adib bin Muhammad Syahrizal. My register number is 24DKM21F1106.
My name is Mara Insyirah binti Mazlan and my register number is 24DKM21F1118.
Hi, my name is Muhammad Amir Rahman bin Nama Zaman. My number matric is 24DKM31F1130.
Hello, my name is Muhammad Afzan bin Yazmi. My register number is 24DKM31F4136.
For this mini project, we have decided to make water bottle submarine, which use Archimedes principle. Submarine is a watercraft capable of independent operation underwater. It differs from a submersible which has more limited underwater capability. It is also sometimes used historically or colloquially to refer to remotely operate vehicles and robots, as well as medium-sized or smaller vessels, such as the midget submarine and the wet submarine.
To prove the theory about Archimedes principle by demonstrate that the submarine sink when the ballast tank filled with water and float when compressed air push the water out of the tank. For this mini project, we use one recycled 1.5 liters plastic bottle, a recycled rubber band, a balloon that takes 50 cents, and 50 cm plastic tube that takes 2 rm. For us, it only takes 7 minutes to complete the whole mini project. First, we make a 6 mm hole on the bottle. Second, insert the plastic tube. Third, tie the balloon to the plastic tube with rubber band. Fourth, make 6 holes in 1 cm around the bottle.
Firstly, fill the bottle with the water and let the bottle sink. After that, blow the tube until the balloon inflates. The water bottle submarine will float to the water surface.
This figure shows a submarine floating on a sea surface. The density of the seawater is 1020 kg per meter cube. Calculate the weight of the floating part of the submarine. For this question, we use the buoyancy force formula, which is F equal rho Vg. So the solution is F equal 1020 times 1.5 times 9.81. So the weight of the floating part of the submarine is 15,009.3 Newton. Using Archimedes' principle, it is clear that a change in mass of an object affects how much liquid has to be displaced. In submarines, this is controlled by ballast tank. When the tanks are empty, the submarine has less mass and it flows like a normal ship. Compare the weight of the submarine to the buoyant force of water. While the A. ballast tanks are empty, B. ballast tanks are filled with water, C. compressed air push the water out of the tank. In picture A, we have neutral buoyancy. The weight of the submarine equals the amount of water it deflates. In picture B, we have negative buoyancy. The amount of water inside the ballast tank is more than the amount of water displaced, causing it to sink. Also, the air is released from the submarine, so the density in the submarine is greater than the surrounding water. In this picture, we have positive buoyancy. The water in the ballast tank is vented from the submarine, so it means that its density is lesser than the surrounding water.
Archimedes' principle states that the upward buoyant force that is exerted on a body immersed in a fluid, whether fully or partially, is equal to the weight of the fluid that the body displaces. Archimedes' principle is a law of physics fundamental to fluid mechanics. It was formulated by Archimedes of Syracuse.
The bottle sink when it filled with water and floated when the plastic tube blown and the balloon inflates. The submarine carries cylinders of compressed air. When it is made to rise to the surface, compressed air is used to force the water out of the ballast tanks. The submarine also can explain by Applying Archimedes principle, we can show that the objective of this project was achieved and the water bottle submarine fully functional.
That's all from Muse. Thank you.